and welcome back to Knowledge on Ears. In today's video, we are going to be taking a look at Newton's third law of motion and what it is. And today's video is going to be divided into two main parts. First, we're going to take a look at what the law really is. And second, we are going to see a super cool experiment where we're going to have a rocket and we are going to launch it off. So let's get going. So what is Newton's third law of motion? Well, the textbook definition is right here. Basically, it says every action has an equal and opposite reaction. What does that mean? Well, let's see. So let's say we have object A and we have object B. And object A and object B collide. That means object A, let's just call it FA. Object A is exerting a force of Fa on object B. And according to Newton's third law of motion, object B will exert an equal and opposite force back on object A. That's basically what Newton's third law of motion is. It's super simple. Let's look at another example. Let's say this stick figure is you. And this is the box that you want to move. So to move it, you're going to push it. And you're going to push it with a force of, again, let's call it Fa. So again, according to Newton's third law of motion, the box will exert an equal and opposite force back on you. So it's opposite and it's equal, so Fb. So you may be thinking that if Fa and Fb are equal and they're in opposite directions, they must be canceling out. So in the end, nothing is moving at all. Everything is staying in the same position. No, that's not what's happening. What's happening is that both of these forces are exerting on different objects, not the same one. So it's not canceling out. Fa is being exerted on the box, but Fb is being exerted on you. So in the end, they do not cancel out. Now, we're going to take a look at the example of a gun and a bullet. So we already know, when we shoot a gun, the bullet moves out of the gun at a very high speed. And we also know that the gun kind of moves back a little bit. That's known as recoil. So why does this happen? Well, it's because of something known, once again, as Newton's third law of motion. So let's check this out. When we shoot the bullet, it moves out at a force, and let's call that Fa again. And according to Newton's third law of motion, we already know that there's going to be an equal and opposite force. So it's going to be opposite, and we'll call it Fb. So both of these forces have to be equal. So how does it feel like? Why does it feel like the bullet is moving so much faster than the gun recoil, than the opposite force? Because when we shoot it, the bullet moves so much faster. Well, that's because of something known as Newton's second law of motion, known as force is equal to mass times acceleration. This is Newton's second law of motion. And what this is that it summarizes the relationship between mass and acceleration. So mass and acceleration are inversely proportional. So if force stays the same, then if mass increases, acceleration decreases. Acceleration increases, mass decreases. So in terms of the gun, if we have Fb exerting onto the gun and it has a larger mass, it's going to have a smaller acceleration. So it's going to move back less than the bullet because the bullet has a smaller mass. So it's going to have a larger acceleration since Fa and Fb are equal. So now that we've understood what Newton's third law of motion is, let's see how our rockets work. Take a look at this. Over here we have a super cool rocket. And inside this rocket, there is a matchstick covered by aluminum foil. So when we light up this matchstick with a fire, it starts flying. Why? Because of Newton's third law of motion. In this case, what's happening is when you light it up, gases are being created inside. And then these gases escape from the back. That is the action. And obviously, we know that there's going to be an equal and opposite reaction. In this case, that equal and opposite reaction is when the rocket moves forward. So, Now we are going to take a look at how we can build these rockets at home. Over here I have a sheet of aluminum foil and I also have a matchstick. And so I'm wrapping the aluminum foil around the matchstick. Make sure that the pink part of your matchstick is at the top, where I'm pointing right here. Make sure that happens because you have to light up the pink part. So now you have your matchstick. I hope you enjoy very much and thank you for watching the video. Bye!